Hello guys, sorry for the long break without videos. I've been completely busy with my work and I almost lost an eye along the way. So now I'm back. So look at this. This is the Swagger page of a FastAPI app. So we'll use Python this time. I asked a question just here, how to fetch with an ORM in Next.js, and right here there is the answer and the sources of the response. This is the source URLs it used to generate the answer. So this is not just trust me bro AI, this is answer, timing, and receipt. In this video, I'm showing a production-ready RAG documentation system I built. We won't go through the code line by line. Instead, we will focus on explaining the overall workflow of this application. It's FastAPI for the REST API, LongChain for the RAG chain, ChromaDB for the vector store, and OpenAI for embeddings and the generation of the answers. The goal is simple. Instead of hunting through documentation, you index it once and then you talk to it. Let's do the fun part first. This is a FastAPI API, so Swagger is basically free, and I love free. There is 4 endpoints on this application. Step 1, indexing. We want, for this example, to index this page, okay, fetching data right here. So we have different section. We will try it out. So I click here, I verify the address, okay, and I execute the request. This endpoint crawls the documentation starting from this prefix, discovers pages, fetches their HTML, parses the content into clean sections, splits everything into chunks, generates embeddings, and stores it in a local vector database. That's a lot, but the point is, after this, the docs become searchable semantically. So this request is successful. Now we can ask about whatever we want on the fetching with Next.js. Okay, so I will ask this question again, execute. How to fetch with an ORM in Next.js. Okay, I got the answer. To fetch data with an ORM in Next.js, blah blah blah. And the sources. We can see that the sources are this URL. So if we go to this section with an ORM or database, we got this answer. To fetch data with the fetch API. Now this part, since server components are rendered on the server, you can safely make database queries. Turn your component to an asynchronous function. Okay, and there is all post, and in the answer just here, we got all post. Okay, so the response include the example in the documentation. So that's pretty cool. If I ask another question, how to use remote images in Next.js, okay, the answer is this information is not present in the provided documentation. Good, that's what we want. So this one is to query the documentation, and this one is the indexing request. This is the please be patient, I'm hitting the internet endpoint. So here is the mental model. Okay, this part. RAG means retrieval first, generation second. So the system doesn't know the docs, it looks up the relevant passages, and then the model explains them. That's how you get answers that are much more reliable than pure chat. Now let's connect the demo to the code. We'll go into the src folder, then in API to see the routes, different routes of this app, of this API. So we got this endpoint, post/URLs, to index our pages and our documentation. 2, we got this get/to-query. 3, we got get/else to check if the vector store exists. And then we got delete/index to clear it. I also restrict, where it is, just here. I also restrict crawling to an auto list of domains. By default, it's next.js.org. This is a simple guardrail, so the crawler doesn't go exploring the entire web, but you can change it. You can set multiple domain. You do what you want. So we'll check the crawler. So we go to the core folder, and in scrapping folder, we watch crawler.py file. Just here. So first step, page discovery. I use Selenium with headless Chrome. So why Selenium? Because a lot of documentation sites load navigation links dynamically with JavaScript. So if I only use raw HTTP plus HTML parsing, I'd miss pages. The crawling strategy is basically BFS, so I keep a queue of URLs to visit, a set of visited URLs, and I extract links from a tags. Then I normalize URLs, I keep the same domain, and I enforce a prefix so we stay inside the docs section. And there is a max pages limit, so it remains controllable. After discovering pages, I fetch the HTML. So I just get the entire list of tags from a page, and then I have to parse all the HTML. So I will go to this file, html parser.py. I go there. This is where quality really matters. First, I remove noise like navbars, footers, scripts, the style, etc. Then I rebuild here the content into structured sections using headings like H2, H3, and H4. Each section becomes a long chain document with metadata, and the metadata includes the page title, section headers, and the URL, so we can later return sources. Next, chunking. I split document into smaller chunks with overlap. Too large and your prompt becomes huge. Too small and you lose context. So chunk size and overlap are configurable. Now we persist everything in a vector store. I'm using ChromaDB stored locally in the docs_db folder. This manager class keeps it clean. Build, load, and clear. Build recreates the store from documents. Load uses the existing store at query time, and clear wipes it when I want a fresh index. For embeddings, I use OpenAI, just here. So yes, you need an OpenAI API key in .env. No key, no magic. After this, for the querying, we'll go into the RAG folder in Retriever to retrieve all the vector. When a question comes in, we do semantic search in the vector store. I retrieve the top results with sources. Then I filter results using a distance threshold. This is important because irrelevant context is one of the fastest way to get garbage answers. If nothing is relevant enough, I prefer to return no context than to hallucinate. Then come the generation step, just here. I'm using GPT-4o Mini as a model, and I set the temperature to 0 for consistency, and the prompt is strict on purpose. It says answer only from the provided context, and if the context doesn't contain the answer, the assistant must explicitly say it's not in the provided documentation. This is basically putting the model on a leash. And it's the difference between a fun demo and a system you can actually trust. I also keep track of which documents were retrieved, so the API can return the source URLs next to the answer. Everything is configurable through environment variables, chunk size, overlap and similarity threshold, so you can tune it depending on the type of documentation you index. So that's the project. A modular FastAPI backend, full indexing pipeline, persistent vector storage, strict RAG chain, and source attribution. This is not just a toy, it's a strong foundation for an internal documentation assistant. If you're building RAG systems, here's the takeaway. Do retrieval first, be strict with prompts, store metadata everywhere, and always return sources. If you want a part 2, I can add a simple UI, speed up indexing with parallel fetching, and add auth plus rate limiting for production. Tell me what you'd like to see, and if this helped you, consider subscribing. See you!